हेलो स्टूडेंट। आज हम इंजीनियरिंग केमिस्ट्री का जो चैप्टर है दैट इज़ वाटर टेक्नोलॉजी उसमें से डिटर्मिनेशन ऑफ हार्डनेस बाय ईडीटीए मेथड दैट इज इथिलीन डायमीन टेट्रा एसिटिक एसिड which is a complexometric agent used to determine the hardness of the water. So what is EDTA? So EDTA is nothing but a ethylene diamine tetraacetic acid. Okay, so this is a complexometric agent and used in this titration. How is the structure of EDTA? So this is the structure of EDTA. It is very simple. If you look at the name EDTA, ethylene diamine, that means is having a 2 nitrogen, and tetra means 4 acetic acid group. Okay, so this is the structure of EDTA, that is ethylene diamine tetraacetic acid. So in ion form, the structure of EDTA is like this. This is structure of EDTA. If we use it as a sodium salt, then it form a structure like this. Now EDTA is a hexadentate ligand. What is meant by hexadentate ligand? So this EDTA attached to the central metal like a calcium and magnesium which is present in a water. So it form a complex with a calcium and magnesium present in water. Its density is 6. That means it attached to the central metal at a 6 point. So what are the 6 points? First one is this oxygen, second one is this oxygen, then third this oxygen, fourth this oxygen, and the lone pair present on the nitrogen. So in this way it attached to the metal at a 6 point and form such a complex structure. So that's why it is also called as a complexometric agent. Okay, now next. So here the metal, the M is written here is nothing but a metal, that means the hardness producing salts which are present in a water like a calcium, magnesium. Okay, so now next. Now we will discuss how can we determine the hardness of a water. Now here in this titration method we use EBT, that is Eriochrome black tea, as a indicator. That means if we take water samples and we add the EBT, that is Eriochrome black tea, as an indicator. So Eriochrome black tea is a alcoholic solution of the blue color dye, so which used to indicate the endpoint, and this is the structure of EDTA for your kind information. So in this way we can write the structure of EBT, that is Eriochrome black tea. Now how is the reaction? So initially we have to take a water sample in a conical flask like this. Suppose this is a conical flask, and you have to take it a water sample. Okay, from burette. Suppose this is a burette. We have to add the EBT in the solution. So when we add EBT, then the color becomes wine red. That means the metal react with the Eriochrome black tea indicator and form metal EBT complex. Okay, what is the color? The color is a wine red color of the solution. Once we add the EBT, then we have to titrate it against the EDTA solution, right? So we have to add EDTA from a burette. So here is the reaction. So initially, so metal EBT complex is formed. Its color is wine red, right? Now we have to add EDTA. We have to add EDTA so that the EDTA replace the EBT and form a metal EDTA complex. Now the metal EBTA complex is a more stable. That's why it replaced the Eriochrome black tea. Now once all the EBT present in the complex is free, then finally the wine red color of the solution it changes to blue. All the EDTA replace all the eriochrome black tea molecules and form a metal EDTA complex. At this point, the titration is completed and the end point is shown by the color change. That is, initially the color is a wine red in color, right? Now initially, the metal EBT complex color is a wine red, but after complete removal of the eriochrome black tea, the color is a blue color. That means it changes from wine red to blue. This is a indication that the titration is completed and the metal EBT complex, metal EDTA complex is formed. Here is the metal EDTA complex, which is a stable complex. So in this way, the EDTA traps the metal ions and form a complex with them. So we can determine the hardness of the water by using the EDTA and eriochrome black tea as a indicator. So this is all about the procedure of determination of the we can say hardness of the water. So from the observations and calculations, finally we can conclude that how much hardness is present in that water in a milligram per liter or ppm. Okay, so this is all about determination of hardness by EDTA method. So thank you.